This lesson will cover the following topics. The hot loop. The hot loop within the engine compartment. The hot loop within the passenger compartment. The air conditioning adjustment is the result of the air from the hot loop being mixed with the air from the cold loop. This section will show how the heating function is performed in the hot loop. The engine is the main source of heat used to heat the air in the passenger compartment. Combustion supplies calorific energy as well as kinetic energy. This calorific energy heats the engine coolant. The coolant flows through a heater matrix designed to improve the comfort of the passengers. Let us look first at the components in the hot loop within the engine compartment. The components in the hot loop within the engine compartment regulate and maintain the engine temperature. The hot loop is made up of the following components: the cooling radiator, the cooling fan assembly and temperature switch, the thermostat, and the engine temperature sensor. Flexible and rigid pipes are used to connect these different components. Let us look now at the components in the hot loop within the passenger compartment. The hot loop within the passenger compartment is made up of the following components: the heating unit, the heater matrix, the control panels, and the temperature indicator. The components in the hot loop within the passenger compartment heat, distribute and divide the air. These components also give information about the engine temperature and process the user's requests. In this section, we covered the following points. The combustion in the engine supplies the calorific energy used to ensure the thermal comfort of the passengers. The components in the hot loop within the engine compartment regulate and maintain the engine temperature. The components in the hot loop within the passenger compartment heat, distribute and divide the air. We shall now look in detail at the operation of the components in the hot loop within the engine compartment. Let us start with the cooling radiator. The cooling radiator is located at the front of the vehicle. The radiator evacuates the heat released by the engine in order for it to maintain a constant temperature. The coolant contains the heat released by the engine and enters the radiator hot. The heat of the coolant is then released via the flow of air through the radiator. In some cases, the airspeed is not sufficient to lower the temperature of the coolant. The cooling fan assembly accelerates the thermal exchange between the air from the radiator grill and the radiator. The cooling fan assembly is composed of one or two fans located upstream or downstream of the radiator. Let us now look in detail at the operating principle of the ventilation speeds when the vehicle is fitted with a fan. The temperature switch informs the computer to activate the first ventilation speed. The computer then controls a relay via a resistance fitted in series. The first ventilation speed is engaged. It is designed to stabilize the operating temperature of the engine. If the coolant temperature increases, the sensor informs the computer. The computer controls a relay that supplies the fan with battery voltage. The second ventilation speed is engaged, which increases the heat exchange between the radiator and the exterior air. When the vehicle is fitted with two fans, the ventilation speed is modulated by an assembly of 3 relays. 2 relays supply the fans in series. When the first speed is engaged, the computer controls 1 relay. The 2 others remain on standby. When the coolant temperature increases, the unit supplies the other 2 relays. These 2 relays supply the 2 fans with battery voltage. The second ventilation speed is engaged. Let us now look at the role of the thermostat in the hot loop within the engine compartment. The thermostat adjusts the circulation of the coolant in accordance with the engine temperature. The thermostat is located in the water outlet unit, positioned on the cylinder head. The water outlet unit is connected to the assembly of pipes in the coolant circuit. Let us now look in more detail at the operation of the thermostat. The thermostat is composed of a wax capsule, a fixed needle, a valve, and a return spring. At first, the coolant only circulates in the engine block. The wax expands with the effects of the heat. The expansion of the wax causes the body of the capsule to move via the needle. The valve opens and circulation is possible. When the temperature decreases, the spring brings back the capsule and the valve returns to the closed position. Due to the thermostat, the rise in temperature of the engine and heater matrix is faster. Let us now look at the warning light and engine temperature gauge. The warning light and gauge are located on the instrument panel. Some vehicles only have the warning light. When the engine starts, its temperature rises progressively. If the hot loop is not working correctly, the warning light indicates engine overheating. Let us now look at testing the components in the hot loop within the engine compartment. The cooling fan assembly, temperature switch, temperature sensor, and engine temperature warning light may be checked visually and electrically. The visual check can be carried out when the system is activated or by checking the electrical connections. The electrical check can be made using the fault-finding tool or the multimeter. The thermostat is checked visually when it is in use. In this section, we covered the following points. The cooling radiator is used to evacuate the heat released by the engine in order for it to maintain a constant temperature. The cooling fan assembly accelerates the thermal exchange between the air from the radiator grill and the radiator. The second ventilation speed is engaged if the coolant temperature increases. The thermostat adjusts the circulation of the coolant in accordance with the engine temperature. Due to the thermostat, the rise in temperature of the engine is faster, which enables the heater matrix to heat up more quickly. If the hot loop is not working correctly, the warning light indicates engine overheating. Let us now look at the components in the hot loop within the passenger compartment. Let us start with the control panel. The control panel enables the user to activate and adjust the different air conditioning functions. Depending on the vehicle type, there are different air conditioning zones in the passenger compartment. In some vehicles, there are as many control panels as there are air conditioning zones. A single zone adjustment control panel is used for uniform distribution of air conditioning in the vehicle. The two-zone adjustment control panel is used for distribution of air on each side. The multi-zone adjustment control panels are used for distribution of air in each row. Here is a manual adjustment control panel. If the adjustment is in manual mode, the functions are engaged and adjusted by the user. The air conditioning function requests that the cold loop compressor be activated. If the max AC button is pressed, the compressor flow is at its maximum. The recirculation function insulates the vehicle from the exterior air and allows the desired comfort in the passenger compartment to be more efficiently attained. The de-icing function affects the electrical functions of the rear screen and the de-icing rear view mirrors. The demisting function affects the distribution of air towards the demisting vents. The ventilation function allows the passenger compartment fan speed to be adjusted. The air distribution function affects the position of the distribution flaps. The temperature function affects the mixing of the air from the cold loop with the air from the hot loop. Here is an automatic adjustment control panel. If the adjustment is in automatic mode, the functions are engaged and adjusted by the system. The user can return to manual mode by pressing a button other than the temperature control. The automatic function is used to engage the air conditioning automatic adjustment mode. The passenger compartment temperature indicator displays the temperature requested by the user. However, the value displayed is not always the actual value in the passenger compartment. Let us now introduce the heater matrix. The heater matrix encourages heat exchange between the filtered air and the engine temperature in order to heat the air in the passenger compartment. The heater matrix is incorporated in the heater unit and connected to the engine coolant circuit. At the heater matrix inlet, the temperature is the same as the engine coolant. The coolant flows through the different parallel pipes of the heater matrix. At the heater matrix outlet, the coolant, cooled by the passenger compartment fan, returns to the engine. We shall now introduce the role of the heater unit. The heater unit is usually located in the passenger compartment or in the subframe. The heater unit includes the distribution components for division and recirculation of the air. The heater unit also includes the passenger compartment fan, evaporator, and the heater matrix. The heater unit is used to mix the air issued from the cold and hot loops to manage the recirculation function and the air distribution in the passenger compartment. We shall list each of the functions performed by the heater unit. Let us begin with air inlet management, performed by the recirculation flap. The role of the recirculation flap is to prevent the admission of exterior air under certain conditions. The recirculation flap is located at the inlet of the heater unit after the passenger compartment filter. In its open position, the recirculation flap allows exterior air to enter the heater unit. In its closed position, the recirculation flap closes the exterior air inlet and allows the interior air to be recirculated. The recirculation flap can be controlled by wire, a direct current motor, or a stepper motor. We shall now look at air recirculation in more detail. Recirculation allows occupants to isolate themselves in the event of external pollution. Recirculation is the continual cooling or heating of the passenger compartment air to obtain the thermal comfort required quickly. In manual mode, it is preferable not to leave the recirculation function on for too long, so as to renew the interior air regularly. In automatic mode, the recirculation flap renews the air every 10 minutes. We shall now look at air distribution, handled by the heater unit. Air distribution consists of mixing the air from the hot and cold loops to attain the level of comfort requested. Air distribution is performed by the mixing components. The mixing flaps are located downstream of the evaporator, the cold producer. The mixing flaps can be controlled by wire, a direct current motor, or a stepper motor. Let us look at the principle of mixing. This is the basis of air conditioning temperature adjustment. The air entering the heater unit always passes through the evaporator. If cold air is requested, the compressor starts and the evaporator cools the air that passes through it. In this case, the mixing flap closes off the air's access to the heater matrix. If hot air is requested, the evaporator is at the same temperature as the incoming air. In this case, depending on the temperature requested, the air is partially or fully directed towards the heater matrix using the mixing flap. If the demisting function is requested, the air is dehydrated as it flows through the evaporator, then heated by the heater matrix. After recirculation and division, let us look finally at the distribution of air in the vehicle. Distribution consists of directing the flow of air to the different sections of the passenger compartment. Air distribution is performed by the distribution components. The distribution flaps are located at the outlet of the heater unit. The flaps can be controlled by wire, a direct current motor, or a stepper motor. Depending on the request, the distribution flaps direct the air in the vehicle's ventilation circuit. Depending on the vehicle type, the ventilation circuit includes pipes incorporated in the dashboard, A-pillars and B-pillars. Depending on the vehicle type, the air can be blown through diffusers at floor level and demisting vents. Air can also be blown through vents at the level of the dashboard and the top of the head. Let us look at the 5 combinations of air distribution. All the airflow is directed towards the demisting vents on the windscreen and side windows. The airflow is directed towards the demisting vents on the windscreen, the side windows and footwells. The airflow is directed towards the vents and footwells. The airflow is directed towards the vents only. The airflow is directed towards the footwells only. Let us now look at testing the components in the hot loop within the passenger compartment. The control panel and recirculation, mixing and air distribution functions can be tested visually and electrically. Electrical connections may be checked visually and/or by manipulation. The electrical check can be made using the fault-finding tool or the multimeter. The heater matrix is checked visually when it is in use. In this section, we have covered the following points. The control panel enables the user to activate and adjust the different air conditioning functions. The heater matrix encourages heat exchange between the filtered air and the engine temperature in order to heat the air in the passenger compartment. Recirculation is the continual cooling and heating of the passenger compartment air to obtain the thermal comfort required quickly. Air distribution consists of mixing the air from the hot and cold loops to attain the level of comfort requested. Depending on the temperature requested, the air is partially or fully directed towards the heater matrix using the mixing flaps. Distribution consists of directing the air to the different sections of the passenger compartment by means of the distribution flaps.